Have you ever, say, had a loan application denied, and you're just left wondering why?
Mhm.
Or maybe you've heard about AI systems helping with medical diagnoses or, even making recommendations in courtrooms.
Yeah, it's becoming so common.
It really is. It's kind of astonishing how deeply AI is getting woven into our lives. And, well, as we rely on it more, this big question keeps coming up.
Yeah.
How and why are these systems making these really important decisions?
It's such a crucial question because, when AI just acts like a black box, it's understandable that people start to lose trust.
Right.
If you can't get a handle on the reasoning, how can you really trust the outcome? That opacity, it's a real barrier.
That's a really powerful point, and it perfectly sets up why today's deep dive is all about explainable artificial intelligence, or XAI.
Mhm.
It's this really vital characteristic for building that trust we need in AI systems. And
Mhm.
to help us navigate this pretty complex area, we're mainly drawing from a key source, NIST 8312.
Ah, yes, the NIST publication. Very significant.
Exactly, from the National Institute of Standards and Technology. So, our mission today is basically to unpack NIST's 4 fundamental principles for explainable AI.
Okay.
We'll explore what they mean in practice and, why these principles really matter for anyone who interacts with AI, which is pretty much everyone these days.
It really is a complex space, no doubt. And there's this huge global push for more trustworthy AI, right? Explainability is just one piece, but a critical one.
Alongside things like accuracy, privacy.
Exactly. Accuracy, privacy, reliability, trying to mitigate harmful bias.
Hmm.
But honestly, without explainability, tackling those other concerns gets incredibly difficult. You need to see why something might be biased or inaccurate.
Okay, so let's dive in. To start understanding what explainable AI actually means, where does NIST begin? What's the first step?
Well, they start with the first principle, simply called explanation.
Explanation, okay.
And the principle basically says that an AI system must deliver or contain accompanying evidence or reasons for its outputs and or processes.
Hmm.
The key thing here, and it's sort of the bare minimum, is just that an explanation exists. It moves AI from being a total black box to maybe a gray box.
So it's not imposing quality rules yet, just?
Uh-huh.
Is there anything?
Precisely. So that loan application system you mentioned earlier, if it just spits out denied, full stop,
Yeah.
that doesn't meet this principle. But if it says loan denied because your credit score was below our threshold, well, that starts to meet it.
I see. So even if it's not the whole story, just getting some kind of reason back is that first step. It cracks open the box a little.
Exactly. For a system to even be considered explainable, it has to provide some kind of evidence or reasoning. Otherwise, you're just left completely in the dark.
Okay, so step 1, get something. But, that's clearly not enough on its own, is it? That must lead us straight into the second principle.
It does. That's the meaningful principle. This one requires that a system provides explanations that are understandable to the intended consumer.
Ah, the intended consumer. That sounds key.
It really is. Because, as the NIST document puts it, one-size-fits-all explanations do not exist. What counts as meaningful? Well, it totally depends on who's receiving the explanation.
Right. Like an AI developer digging into why a model failed. They need super technical details, right?
Absolutely. Debugging information, maybe parameter weights.
Which would be completely useless, or worse, confusing for, say, a policymaker trying to understand fairness implications, or just me trying to figure out why my loan was denied.
Exactly. It's like the analogy they use is quite good. Think of a neuroscience professor.
Okay.
When explaining a new finding to a colleague, they'll use all the technical jargon, the detailed methods. But explaining the same finding to an undergraduate class, they simplify.
Yeah, different level.
And then explaining it to friends or family with no science background. It's simplified even further, probably using analogies, focusing on the gist. The explanation has to be tailored, otherwise it just doesn't land. It's not meaningful.
That makes perfect sense. Tailoring is everything. So, okay, we need an explanation, principle 1, and it needs to be understandable to the right audience, principle 2, meaningfulness. But what if it's understandable, but they're just plain wrong?
Ah, yes. That brings us to the third and incredibly critical principle, explanation accuracy.
This sounds vital.
It really is.
Yeah.
Explanation accuracy means that an explanation correctly reflects the reason for generating the output and/or accurately reflects the system's process.
Okay, so it has to be true to the system's internal logic.
Exactly. And here's the crucial distinction they make. This is different from decision accuracy.
How so?
Well, An AI could actually make the correct decision. Let's say it correctly identifies a bird in a photo as a robin.
Okay, correct output.
But the explanation it gives for why it thinks it's a robin could be completely false. It might say because of the yellow beak, when robins don't have yellow beaks, and maybe it actually keyed off the red breast but misreports it.
Wow, okay, so the AI gets the right answer, but its reasoning, or at least the reason it gives us, is totally flawed. How does that play out in the real world? Why is that dangerous?
Oh, it can be incredibly misleading. Think about, say, a face recognition system helping an examiner.
Right.
An accurate explanation might highlight the specific facial features the AI used, helping the human make a better final judgment.
Mm.
But an inaccurate explanation, it could point the examiner towards irrelevant features, potentially causing them to make a wrong identification.
That's serious.
Or consider the judicial system example again. An algorithm recommends a certain sentence length. If the explanation for that recommendation is inaccurate, maybe it says it weighed factor X heavily, when it's actually weighed factor Y, it could lead to a profound miscarriage of justice. People might trust the explanation and not dig deeper.
That's genuinely chilling. It puts so much weight on getting the explanation right, not just the final answer.
It does. And it also brings up a tricky trade-off, right?
Mm-hmm.
Sometimes a super detailed, highly accurate technical explanation might be less meaningful to a regular user because it's just too complex.
Right, that balance between accuracy and understandability. Okay, that leads us to the fourth principle. What happens when the AI is, out of its depth or just not sure?
That's where the final principle, knowledge limits, comes in.
Yeah.
It basically dictates that a system only operates under conditions for which it was designed and when it reaches sufficient confidence in its output.
So it needs to know what it knows and perhaps more importantly, what it doesn't know.
Precisely. This is a huge safeguard for building and maintaining trust. It stops the AI from just guessing or making stuff up when it encounters something unexpected or confusing.
So it prevents unreliable answers. How does a system actually, hit these limits?
NIST highlights two main ways. First, it might be asked to operate outside its intended domain.
Like asking a cat identifier to identify a car.
Exactly. Or, their example, a bird classification system gets an image of an apple. A good explainable system shouldn't try to classify the apple as some weird bird.
Right.
It should recognize it's not in its knowledge base and explain something like, I could not find any birds in this image.
Okay, that makes sense. What's the second way?
The second way is when it is operating within its domain, but it just doesn't have high confidence in its answer.
Ah, like a fuzzy picture.
Perfect example.
Yeah.
That same bird system gets a really blurry photo. It might be able to tell there's something bird-like there, but it can't be sure what species. So it should communicate that uncertainty.
How would it phrase that?
It might say something like, I detected an object that might be a bird, but the image quality is too low for me to identify the species confidently.
That's incredibly useful. It's like AI with a dose of humility.
You could put it that way. It's about transparency regarding its own limitations.
So bringing it all together then, the real power of explainable AI isn't just having one of these principles, but having a system that adheres to all four.
That's the core message. Explanation, meaningful, explanation accuracy, and knowledge limits. They work together.
Because an explanation that exists but isn't understandable or isn't accurate or pretends to know more than it does, well, that's not very helpful, is it?
Exactly. It could actually be worse than no explanation at all, because it might actively mislead you. The strength comes from the combination.
Okay, so we've got a solid grasp on these four principles that define a good explanation. But you mentioned earlier, an explanation isn't just this static thing that pops out. The how and why it's delivered seem just as important.
Oh, absolutely. The context matters immensely. Why is someone asking for an explanation in the first place? That really shapes what kind of explanation is needed and how it should be presented.
What are some of those different reasons, those purposes?
Well, think about AI developers. They often need explanations for debugging, right? To figure out why their model's making mistakes, or maybe to check if the training data had issues.
Okay, so internal system improvement.
Right. Then you have regulators. They might need explanations to ensure a system complies with laws like anti-discrimination laws or rules about credit reporting, like the Fair Credit Reporting Act or GDPR in Europe.
So accountability and compliance.
Exactly. And then there's the end user perspective, maybe customer relations. Explanations there are about clear communication, building understanding, maybe giving someone grounds to appeal a decision.
So the why behind the request really changes the what and how of the explanation.
Fundamentally. And NIST breaks down how explanations can vary using these style elements.
Okay, let's unpack those. What's the first style element?
The first is level of detail, and this connects directly back to the purpose we just discussed.
Right, so it can vary a lot.
Massively. It ranges from what they call sparse, very brief, high level, all the way to extensive.
Can you give an example of sparse?
Think of an emergency alert system, maybe a tornado warning. Take action. Message pops up in your phone.
Okay, yeah.
Very direct. The explanation there is minimal, right? It doesn't tell you the specific atmospheric conditions causing the tornado warning. But in that context, brevity is key. You need people to understand quickly and act fast. Detail would just slow things down.
Got it. And extensive.
That would be the opposite end. Imagine a detailed report for that AI developer showing internal calculations, feature importance scores, step-by-step processing, everything needed for deep debugging.
So tailoring the amount of information makes sense. What about interaction? Can the user, talk back to the explanation?
Yes, the degree of human-machine interaction. This is really interesting. NIST outlines 3 levels here.
Okay.
The simplest is declarative. The system just gives you the explanation, take it or leave it. No follow-up questions possible within the system itself.
Like a fixed statement.
Exactly. Like that loan system, always giving the same canned reason for a certain type of rejection. Or an image classifier showing a saliency map. Those heat maps that highlight which parts of an image the AI focused on. It shows you, but you can't directly ask why it focused there through the interface.
Okay, so that's one-way street. What's next?
Next is one-way interaction. Here, the explanation is generated based on a query from the human.
So I can ask it something specific.
Yes. For example, you might ask the system, show me the top 3 factors that led to this decision. Or, visualize the impact of my credit score versus my income. The system responds to your specific request.
Okay, that's more interactive. And the deepest level?
That's two-way interaction. This is pictured more like a real conversation, a dialogue.
Wow.
The human asks questions, but the machine might also ask clarifying questions back, like, what aspect of the decision are you most interested in? Or, would you like me to explore alternative scenarios?
That sounds incredibly advanced. Is that common now? Not really. The source actually notes this is still mostly a future research direction. It's the ultimate goal for many, this kind of collaborative exploration, but it's not widely implemented yet. Something to look forward to, maybe.
Yeah.
Okay, and the last style element was format, how it actually looks or sounds.
Right, the format. Explanations aren't just text. They can be graphical or visual things like charts, graphs, data visualizations, those saliency maps we mentioned.
Visual aids.
Exactly. They can also be verbal, which could mean written reports or even synthesized speech output.
So the AI could literally tell you why.
Potentially, yes. And another important format is visual or auditory alerts. Think about the pitch or pattern of a siren indicating different statuses, or warning lights on a dashboard. These are forms of explanation conveying system state or issues quickly.
It's really about choosing the best way to communicate the information effectively for that specific purpose and audience.
Precisely. And it often involves those trade-offs we talked about, maybe sacrificing some detail for clarity or using a visual format, even if a verbal one could be more precise, just because it's quicker to grasp.
It's clear that XAI is vital for trust and for making AI better. But the source also raises this intriguing point, calling explainable AI a double-edged sword. What are the downsides? What risks can it introduce?
Yeah, that's a really important consideration. While XAI definitely helps us find and fix risks within the AI system itself.
Like bias or inaccuracy.
Right. But the explanations themselves can sometimes introduce new risks. One big one is the potential exposure of proprietary details.
How so?
Well, a single explanation might seem harmless. But if someone, maybe a competitor, can get multiple explanations by probing the system with different inputs.
They could piece things together.
They could potentially reverse engineer too much about how the system works, revealing trade secrets or intellectual property. So transparency needs to be managed carefully.
That's a tricky balance. Too much openness could be a vulnerability. What other risks are there?
A major one we touched on is inaccurate explanations. We already discussed how dangerous these can be.
Leading people to wrong conclusions, biasing judgment.
Exactly. In high-stakes areas like medicine or justice, the impact of a misleading explanation could be devastating. People might overtrust an explanation simply because it exists, even if it's flawed.
That really underscores the need for Principle 3 explanation accuracy to be taken seriously. Are there more devious risks?
Well, yes. There's the risk of adversarial attacks. specifically targeting the explanation mechanism.
Like trying to fool the explanation itself.
Sort of, or using explanations maliciously. One example mentioned is something called fair washing.
Fair washing. What's that?
It's where someone might deliberately create a simple interpretable model, one that looks explainable and fair on the surface.
Okay.
But its real purpose is to mask or distract from unfairness or bias happening in a more complex underlying black box model that's actually making the decisions. The explanation is just a smokescreen.
Wow, that's incredibly sneaky. Using the appearance of transparency to hide the opposite.
It shows that we can't just assume an explanation is trustworthy. We need to be critical, even when one is provided.
Okay, this is all fascinating about AI explainability. But then the source takes this really surprising turn. It asks, how do we humans actually measure up against these same four principles when we try to explain our own decisions?
It's a fantastic comparison, isn't it? It really provides a crucial baseline. We tend to assume we're pretty good at explaining ourselves, but the research, well, it paints a much more nuanced and, frankly, humbling picture.
I'm intrigued. So let's go through the principles again, but for humans. Principle 1, explanation. Can humans generally provide reasons for their actions?
Yes, absolutely. Humans can and do produce explanations for why they did something or made a certain judgment. However,
There's always a however.
there is. The act of actually verbalizing our reasons can sometimes interfere with the underlying thinking process, especially for things we do automatically or based on expertise.
How does that work?
As we become experts at something, whether it's driving or diagnosing an illness, the process becomes more intuitive, less step-by-step conscious thought. Trying to articulate it step-by-step afterwards can be difficult, even inaccurate. The source even says human judgments and decision-making can oftentimes operate as a closed box, just like some AI.
So being forced to explain might actually mess up our intuitive expert judgment sometimes. That's wild. Okay, what about principle 2? Meaningful. Are human explanations always understandable to others?
Well, we try, but the evidence shows there are often big gaps. Think about scientists or doctors trying to explain complex ideas to the public or patients,
Yeah, often doesn't land well.
or the example they cite. Forensic scientists explaining evidence to a jury. Studies find these explanations can be confusing, even misleading, for people without that specialized background. What one person finds meaningful is so dependent on context and prior knowledge. It's a challenge for us, just like it is for AI.
Okay, now for the really interesting one, I think. Principle 3, explanation accuracy. How good are humans at accurately stating the real reasons for their decisions? We feel like we know why we do things, right?
This is where the research is particularly striking and maybe a bit unsettling. There's this concept called the introspection illusion.
Introspection illusion.
It means we often confabulate or basically make up reasons for our choices after we've already made them. We report reasons that don't actually reflect the true mental processes that led to the decision.
We make up reasons after the fact, seriously.
The evidence is pretty strong. Get this. Some neuroscience studies found brain activity indicating a decision had been made up to 10 seconds before the person was consciously aware of having made it.
10 seconds. So my brain decides, and then way later I become aware and cook up a story about why. That's mind-blowing.
It really challenges our sense of conscious control, doesn't it? There are also studies on choice blindness,
Choice blindness.
where researchers subtly swap the choice someone just made, like showing them a picture of a person they didn't choose, when asking why they preferred that person.
And people don't notice.
Often they don't. And what's more, they'll then confidently give detailed reasons for why they preferred the person they never actually chose in the first place.
Okay, that's incredible. So our ability to accurately explain our own motivations is questionable at best.
It suggests we're often not as transparent to ourselves as we like to think. We're masters of post hoc rationalization.
Wow. All right, finally, principle 4, knowledge limits. Are humans good at knowing the boundaries of their own knowledge or competence?
Ah, well, this brings us to the famous Dunning-Kruger effect.
Right, where people who are incompetent at something often overestimate their ability, and experts sometimes underestimate theirs.
Exactly. So
Yeah.
generally, our explicit self-assessment of our overall abilities can be pretty inaccurate. Like me thinking I'm a great singer after one karaoke night, probably not accurate.
Guilty as charged.
However, the source does add a nuance. While our overall self-estimation might be poor, studies show that for a specific decision or task at hand, humans can often judge their confidence level somewhat accurately better than chance anyway.
So we might not know how good we are overall, but we have some feeling for whether we're sure about this particular answer.
Something like that.
Oh.
There seems to be some, maybe limited insight into our immediate knowledge limits for a given task, even if our broader self-perception is flawed.
So putting it all together, the big takeaway here is that we humans actually show, well, pretty limited ability to consistently meet these four principles ourselves.
It's definitely humbling. Explanation, meaningful, accuracy, knowledge limits. We struggle with all of them to some degree.
It really provides a vital benchmark when we think about the standards we're setting for AI.
Absolutely.
Yeah.
It forces us to ask, are we holding AI to a standard that we ourselves don't consistently meet? And what does that mean for trust and accountability?
This whole deep dive into NIST's four principles, explanation, meaningful, explanation accuracy, and knowledge limits, it really gives us such a solid framework for thinking about designing and evaluating AI systems.
Yes, and it's so clear that they really derive their strength when you apply them together. One or two isn't enough.
Right. And when systems do adhere to them, it empowers us, the users, doesn't it? To understand what's going on, maybe change our own behavior based on the explanation, or even appeal a decision we think is wrong.
Exactly. And it's not just for users. It gives developers, auditors, regulators the tools they need to build better, safer, more reliable systems. It's about making AI not just powerful, but genuinely trustworthy.
So here's a final thought to leave you with. As we keep making progress in explainable AI, could we reach a point where some AI systems are actually better at explaining themselves according to these principles than humans are?
That's a provocative question.
If an AI can provide an explanation that is consistently meaningful, accurate, and aware of its limits, perhaps more reliably than a human can, how might that shift our ideas about trust, about accountability, about the whole nature of decision-making in a world that's increasingly shaped by AI?
It certainly makes you think.
We hope this discussion encourages you, our listeners, to think more critically about the AI you interact with every day, maybe even start asking for or demanding better explanations.